Uh, yes, we should have started classes at 8:30, but we were doing theory class until 8 o'clock. So therefore, we had to start the revision class around 8:30. Now the thing is, now optical. Now when it comes to optics, in revision class we have covered refraction through plane surface, refraction through prism, then refraction through lenses. I think we have covered. But we have only two sections pending in optics in the revision class. One is optical instrument, other one is eye defects. Today plan is to discuss optical instruments, but the problem is when it comes to optical instruments, I will try my maximum to brief the points as much as possible. But more than a brief, sometimes I need to draw the ray diagrams and I need to explain. So I am also feeling a bit uncomfortable. The reason is if I start explaining the points further, it might change to a theory class, right? So, but I want to maintain it's a revision class. I want to brief it. I want to summarize everything and I want to give you only the summary. But if when it comes to optical instrument, since there are many ray diagrams linked with that, I'm not that much sure. But because without explaining the ray diagrams, even I tell the stories also, you are not able to understand. In that case, I think I have to draw the ray diagrams, but it's okay. But today we'll plan to cover optical instruments, and I thought of doing sound section also today, but we'll see. With the time I will do until 11:30 continuously. Sometimes I might don't give a break, I might don't give a break, sometimes I give a very small break. We'll see, right? So okay, right. Story is beautiful. Can someone confirm whether everything is okay, whether you can hear me everything nicely, right? Someone put a small reply. Yes, everything is fine. Everything is fine. Now, fine, right? So now, do I want to zoom out? Is this zoom is okay? Do I want to zoom out? Can someone reply? What is preferable? Just reply whether this is fine or shall I zoom out? Tell me. No replies coming from your end. That's the biggest thing that I'm facing. That's the biggest uncomfortable thing I'm facing is I don't get responses from you all. Only one two people who always respond, they respond, but other than that, others I don't see they are replying, they are responding. I don't know why. It's really uncomfortable to do a session like that. Please put some replies. So whether the zoom is fine or shall I zoom out? I don't know why most of you are not responding. Actually, I have no idea. You want to reply for not you? I will tell you again. You want to respond to what account Ace Academy, right? You want to respond for Ace Academy. You want to respond for Ace Academy, right? So likewise, please put some replies. Always think I am talking to you. Always think there isn't any other students. I am talking to you one to one. It's a online video call. I am talking to you. In your if you take a video call, if the one in the phone talking with you, you have to talk in very similar way. You can't talk, please put some replies. So always think in that thing in your mind, right? Okay, session should be start. Also, I will tell you some points. First thing is, remember, right, you are going to face your A level exams within 5 months. April finished, May, June, July, August, September, October. You can think there are around 6 months because sometimes they will keep your exam in November first week, but not that much sure also. So exactly you have 6 months, right? Start writing papers. Come to the paper class. The most important feature in my revision paper class is the model paper class, right? The top priority should be given for the model paper class. Then only pass paper discussion and what? Quick revision. So every day somehow arrange that Sunday time 2 to 3 or 2 to 3:30 time and somehow postpone all your other activities and somehow start writing papers. Start writing papers, start practicing if you are planning to get A result or B result, right? Otherwise, you can't get A's, B's for physics, right? I know some people who do the paper, they are doing, but many, there are around 35, 40 enrollments for this revision class, but only there are around 5 to 10 students are writing. Others, they are justifying. Some of you might don't have might have another class at that time. In that case, please again put a message, then I will try, at least from this week onwards I'll try to give a separate time, but that is not the good option, right? So then at least we can increase the student crowd who is writing the papers. That is important, right? Writing the paper is number one. This revision and everything is number two. Different stuffs, right? Come and write the paper. We are doing something big in the paper class. I have noticed in my past experience, my last two badges, people who came to the paper class daily, people who tried the papers, people who maintained their marks around 50 to 55, they have gone A results, they have gone B results, right? So therefore, if you are planning to get A, B definitely at least from this week onwards, right? Keep a motive. I don't miss any paper class, because you know that it's very rare to find classes where they write the paper. It's very rare to find classes where they mark the papers, where they completely discuss the paper. So therefore, I think you are getting, I think you have got all in one feature. So therefore, get the maximum benefit. We can tell it's okay now. If you don't join online quick revision, if you don't join online past paper discussion, that's okay. Because if you have another class, another theory class, you should give priority for that class. Okay, go to that classes and watch the recordings. But when it comes to paper writing, model paper writing, okay, model paper recording, model paper discussion also, it's okay. Sir, model paper discussion Sunday evening, I can't come because I have another class. That's okay. You go to that class, you watch the recording. But you should watch the recording, all the recordings in that relevant week itself, somehow. But at least in this revision class, at least that Sunday that time, somehow come and write the paper and send me maximum 1.5 an hour, right? That is the important thing. Okay, right? Okay, optical instrument section. Okay, if I brief all the points now, keep your focus, right? I try to explain as much as possible. Okay. Hmm. But we have enough time because we have around 6 months. I think this revision class, we can cover all the sections in the revision class also. You don't worry. Okay. I think we can do a lot of all the past paper questions also. We can discuss more model papers also. Right. Optical instruments story. How to start? Where to start? Mm, right. Right. Okay. Okay. So I will brief it. Okay, and it's not a theory class, but sometimes comparing with all the previous revision sessions, this revision session I might talk little bit wider, because how to talk, then only you will understand. But whatever I explain, keep in your mind, put in your mind somehow. The first story in optical instrument is visual angle. Right, first story, visual angle. I think you have learned this before, but I'm summarizing. Visual angle. What is this visual angle? Symbol is normally we can use alpha. Symbol is alpha. Symbol is alpha. Now, I draw my eye. I draw my eyeball. Look here. Uh, this is my eyeball. Eyeball. I think I haven't. I didn't teach you yet. Eye defects. Normally, when you consider our eyeball, uh, the lens. Okay, there's a lens. When you consider our eye, we can see objects, right? So there is a lens in our eye. That lens is convex. Keep in your mind that point. I think in the revision classes we didn't start eye defects, but keep in your mind when you consider our eyeball, there is a lens. That lens is convex. Okay, that knowledge is more than enough. It's a convex lens. Convex. Okay. Then right. Normally, another point I will tell you. The first point is when you consider eyeball, there is a lens. That lens is convex lens. You know what is convex lens? Revision class we learned. Another point is I will tell you. Second point regarding eye. If you want to see an object very clearly, if you want to see an object very clearly, now you are looking at me, right? If not, you are looking at the table. You're looking at the light bulb. If you want to see objects clearly, an image should be created. An image should be created at the retina. Retina means a kind of, if you are doing biology, you know what is retina. Retina means keep in your mind, in your eyeball, this point. So this region. So this region we are calling as retina. Even if you didn't learn this theory before, you can get all the points. Keep your focus. Retina. Retina. So the second point is now there's an object. There's an object. So you are looking at a tree. You're looking at a tree. So you are looking at a tree. Okay. So this is your object. This is a tree. Your object. So then, what is visual angle? The angle projected by the object at the lens. Look here. So when I draw a light ray, emitting from top point of the object, this light ray, right? So what is visual angle? This angle is we call it visual angle, right? So this angle is we are calling as visual angle. According to vertical opposite angles, we know this angle is also alpha. This angle alpha means vertical opposite angles. This angle also alpha, alpha, alpha. So keep in your mind, this is the object. What would happen? There will be an image. No, this is your object. This is your lens, convex lens. Then we know that there should be an image. Image of this object will be, image of that object will be formed. Image of that object will be formed at the retina. At the retina, right? This red color one is the image, right? What is visual angle? You have the idea, right? Angle subtended by the object at the lens, right? That is the visual angle. The next point is eyeball has a lens, it's convex. The second point, uh, if we can see objects clearly, then that object's image should be formed at the retina. That story. That story. Okay. So the next point is I will ask you what would happen when you move your object far from your eye. What would happen for the visual angle? Now this is my object. If I move this object far from my eyeball, what would happen for the visual angle? Raise your hands. How many of you say visual angle increases when the object distance increases? When the object distance increases, raise your hands. How many of you say visual angle increases and up, visual angle increases and up? Visual angle decreases and up, decreases, decreases. Visual angle decreases. Okay, I will draw that diagram also for your understanding, right? For your understanding that story, that story, right? Just imagine same object, initial this location. You moved this object from here to here. but same object. Object shifted from here to here. So then visual angle, right? When the object is here, this is the visual angle alpha, right? Then the image will be, this is the image, corresponding image. When the object is here, corresponding image will be at the retina. That is, I mark it as I. When you move your object far from the eyeball, far from the eyeball, now the visual angle is low one, alpha dash, right? Now visual angle is lower, alpha dash. So then your image size also small, I dash, right? So then when the distance increases, visual angle decreases. When distance increases, visual angle decreases. That is a point. That is a point regarding the story. All these points keep in your mind. Huh? Not theory class, not theory class, briefing the points. Briefing the points, not theory class. Next one. Next point is what? The next one, right. Okay, next one. So then the story, when distance increases, visual angle decreases. When visual angle decreases, what will happen for the size of the image formed at the retina? When visual angle decreases, ratio and size of the image, even the same object, when distance increases, visual angle decreases, ratio and someone if you say, size of the image also decreases and 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 right. Visual angle decreases means, keep in your mind, image size is decreasing, image size decreasing, image size decreasing. Summary, yeah? This is alpha. Image size means hi, image height ni, image height, image size also decreasing. This is the story, right? Okay, okay, right, okay. Then what? So then, right, okay. Then that story is okay. In our syllabus, we are talking about two different optical instruments. Okay, right? In our syllabus, there are two types of optical instruments we are learning. Okay, optical instruments. We talk about, first of all, we are talking about microscopes. First one is microscope. Second one is telescope. Microscope. Then we are talking about telescope. This is very confusing section for most of the students. I know that. But it's not a theory class, a quick revision. Telescope. Now, every microscope, we talk in microscope, we are talking two different types of microscopes. In microscopes, we are talking about two different microscopes, simple microscope, other one is compound microscope. Simple microscope, other categories, compound microscope. The story is, if it is a simple microscope, all the devices, don't worry if it is microscope or telescope, all are linked with lenses. All these items, all these instruments are made with lenses, especially convex lenses. Microscopes also made with convex lenses, keep in your mind. Telescopes also made with convex lenses. Right? Microscope, there are two categories we are talking, simple microscope and compound microscope. Keep in your mind, simple microscope contains only one lens. Right? Simple microscope contains only one lens. Contains only one lens. Compound microscope, compound, contains two lenses. Two lenses. One lens, two lens. One convex lens. This one contains one convex lens. Your compound microscope contains two convex lenses. Right? We are talking, yeah, okay, microscope, two categories, simple and compound microscope. Simple microscope, we talk about two different stories. Simple microscope under normal adjustment, simple microscope under special adjustment to abnormal adjustment. So we talk simple microscope, two different categories. Simple microscope under normal adjustment, then simple microscope under abnormal adjustment, normal adjustment, abnormal adjustment. Same way in compound microscope also we are talking two stages: compound microscope under normal adjustment, compound microscope under abnormal adjustment. Telescopes uh, only telescopes contains two lenses, two convex lenses. Telescopes contains two convex lenses. In telescope also, we are talking about two stages: normal adjustment stage and abnormal adjustment. If not special adjustment, right? This is the overall content that we are going to learn, right? Overall content that we are going to learn, right? Okay, right? Okay. So then we'll understand. First of all, we'll understand what is normal adjustment and abnormal adjustment, right? Okay. First, we'll talk about microscope. First, we'll talk about microscope. Microscope. Uh, right. Okay. Right. Next story. So you all know linear magnification, right? So you guys all know that linear magnification. We learned in previous revision sessions. In the previous revision sessions, we learned linear magnification. Am I correct? Can you remember what is linear magnification? Linear magnification means we all know linear magnification. You can remember that is equal to image distance over object distance V over U. If not, I told you image height over object height, because tomorrow past paper discussion, all these things are important. Likewise, we are talking about another story, angular magnification. You may be wondering, what is angular magnification? It's a revision class, not a theory class. Huh? Angular magnification. What is this angular magnification? Angular magnification means, okay, magnification means, keep in your mind, like image distance over object distance, like image height over object height. Angular magnification means, keep in your mind, angle subtended by image. Don't worry, I will teach you, right? Angle subtended at the eye by the image, right? Image. So this is important. Angle subtended. You're right. Please write down. Angle subtended at the eye. At the eye by the image. Angle subtended at the eye by the image. Angle. It's a linear magnification. This is a distance ratio. This is a height ratio. Angular magnification is kind of a angle ratio. Angle subtended at the eye by the image over angle subtended at the eye by the object. Angle subtended at the eye by the object. By the object. Now when I tell something like this, I know that most of you don't understand. That's okay. Don't worry, you will understand everything before class finishes. Before class finishes, you will understand everything. Only important thing is until class finishes, until the first break, keep your focus. Now we all know it's a revision class. We are only revising, not detail explaining. But today I am detail explaining because this part is very complex. Right. That is okay. That is okay. Right. Okay. Right. Hmm. Right. Okay. Okay. Right. Hmm. Hmm. Give me 1 second. Give me 1 second. Right. Okay. Now, why are we using microscope? Now, there are two devices. We are talking microscope and telescope. Why are we using microscopes? Very simple. Uh, to enlarge and see very tiny, very small objects that we can't see clearly. For an example, there is a very small ant. You want to see the legs of the ant. From your naked eye, you are not able to see that ant's legs. You are using a microscope to enlarge the legs, right? So basically, microscopes we are using to enlarge small objects nearby us, right? Why are we using microscope? Enlarge very small objects nearby us, right? Enlarge very small objects nearby us. If I ask you, why are we using telescope? In telescope also, as I explained this story, when an object is very far from us, since the visual angle becomes very smaller, there are some objects actually they are very big. Actually, they are very big, but since those objects are very far, we see those objects as very small objects. So we are using telescopes to see objects at very far appearing as small to make it large and see. The best example is we know sun is very huge, but we know since the sun is very far from us, we see sun as a very point object. Actually, sun is very huge. Since sun is at very far from us, we see the sun as a point object. So to clearly, to visually, to enlarge the sun, we are using telescope. Right, the story, a microscope, a smaller object nearby, telescope, large small objects far, right? Small objects far. Microscope, nearby objects, visualize nearby objects. Telescope, visualize very far objects. Nearby object, microscope. Telescope, visualize very far object. Both the objects are seem very small, right? Okay. So now here, next story. Now, when it comes to microscopes, look here, we are defining microscope. Microscope. So we are defining angular magnification for microscope. The same story for microscope. If I define this angular magnification, right? Angular magnification. If I define for microscope, so you should learn by this definition, right? If you can't remember this definition, sometimes you're not able to understand the stories, right? The difficult thing is the definitions and ray diagrams. First of all, we'll understand the definition. right? We now already we know what is linear magnification. Now we talked something about angular magnification. That is a kind of a ratio about the angles made by image and object. Now sir is talking specifically. Now sir is going to define angular magnification specifically for a microscope. Let's see what is definition. His definition is angular magnification for a microscope is, look here, the definition: angle subtended, look, same story, angle subtended at the eye ni. Angular magnification means image ni, image object ni, is dealing angle ni. Numerator is always image, denominator is object. Angular magnification for a microscope means, the definition is angle subtended at the eye. Angle subtended at the eye, same story, angle subtended at the ni, at the eye, angle subtended at the eye, okay, by the image only, by the final image, by the final image, by the final image, right, by the microscope. Here, by the microscope, microscope, 9 o'clock, microscope. Don't worry, we can finish the story. Microscope, over, and denominator is numerator is image, denominator is object ni, over angle subtended at the, same story, angle subtended at the eye only, but naked eye. Now naked means no dress. Likewise naked eye means only through the eye. If you are using a lens, if now you can think that when you are using a lens nearby the eye, if you are seeing an object through the lens, you can think that lens as a dress for that eye, right? If you are seeing something, now you are using glasses, you are wearing spectacles. Spectacles are basically lenses. So if you are looking at now if there's a student who is looking at me through his or her lens, her eye is not naked. He is wearing something to her eye. He is wearing a dress to his eye. That is the lens, spectacle. Then if someone is wearing a spectacle, if someone is using a lens, and if someone is seeing an object, we can't tell that eye is naked. If an eye is naked means remove the dress, remove the spectacle, now look at the object. Now see, this is my object, these are the important points. Keep your focus, right? Because we can't summarize optical instrument like the previous sections. Keep your focus, that's what I can say. This is your object, right? Now you see that I am not wearing any spectacles, I am not wearing any lenses. If I'm looking this object only through my eyes, I can tell my eyes is naked. My eyes naked. I am looking at the object, my eye is naked. Right? Now I am wearing a spectacle. I am using a lens. I am using a convex lens or concave lens. I am using a convex lens, and I am looking at this object again through the lens. And now my eye is not naked. I think you understood what do you mean by the naked. Angle subtended at the naked eye. Naked eye, yeah? Naked eye. Naked. Right? Naked. I don't know the spellings. Naked eye. Placed at naked eye by the object. At near point. By the object at near point. This is the story. Very important equation, learn by heart. At near point. right? The problem is sometimes you might don't know, so what is near point. Okay, then I want to teach you that what is the near point also. I want to teach you what is the near point also. Please learn by heart this angular magnification definition for microscope. For microscope, angular magnification is angles obtained at the eye by the final image by the microscope over angles obtained at naked eye by the object at near point. I will tell you, don't worry, I will tell you. This is very important equation learned by heart, right? Very important equation learned by heart. It's very, very important equation, right? Tomorrow, past paper discussion, when you do it, you will understand it's very easy. Stories. Now, near point means, now I will tell you that point also. Near point means, now let's say now you have a healthy eye. Just think that you are not wearing any spectacles. Your eye is very healthy, right? So now, this is your object. Now you are looking at this object. Now, uh, when this object is very closer to your eye, just think, just take your pens and just keep your pen somewhere distance like this. Keep a pen like this. So just look at your pen. Only focus at your pen. Look at your pen. So then, when you look at the pen, you can see very clearly. You can see the objects, but you should see the objects very clearly. You can see the pen very clearly. What should you do? Please bring the pen towards your eye. Please bring the pen towards your eye. But you should only look at the pen now. You are looking at the pen, but when you are bringing the pen towards your eye, beyond a certain point, your pen is coming more and more closer to your eye. But beyond a certain point, after pen is passed, you can't see the pen clearly. You see there's a pen, but now you see your pen is blurred, right? What is near point? What is near point? In order to see an object very clearly, the minimum distance that you want to keep the object from the healthy eye, right? Near point, right? Near point. If not, we can tell this as least distance of distinction. Near point means this is your healthy eye, right? To see an object very clearly. To see an object very clearly, the minimum distance that you should keep the object from the healthy eye. Generally, for the average, generally, near point for a healthy person is, we identified for a healthy person, near point is how much? 25 centimeter. Generally, for a healthy person, near point is 25 centimeters. Done by art. Near point is 25 centimeters. 25 centimeter, right? Generally, for a healthy eye, near point is 25 centimeter. Near point, right? Also keep in your mind, for a when you consider for a healthy eyeball, diameter of the eyeball is okay. For a healthy eyeball, the diameter of the eyeball, keep in your mind, the diameter of the eyeball is 2.5 centimeter, right? Near point is 25 centimeter. For a healthy eyeball, the diameter of the eyeball is 22.5, 2.5 centimeter. Diameter is 2.5 centimeter. That means in millimeters 25. In millimeters 25. Healthy eyeball. This can vary, right? Sometimes maybe my eye diameter is not 25 millimeters, 2.5 centimeters. My eye diameter can be vary, but generally, as an average for a healthy eyeball, diameter is 2.5 centimeter, right? Some points, some points, these points are important. Time is 19. Still didn't teach you about any optical instrument. Little by little build in the stories. Little by little build in the stories. Okay. Right, okay. Right, okay. Now, uh, microscope, telescope, simple microscope, compound microscope. Uh, First of all, we should understand what is angular magnification. Angular magnification means kind of a ratio between angle made by image and angle made by object. The general definition is like image distance or object distance, image height or object height. Angle magnification means angle made by image, angle made by object. But if I detailedly explain angular magnification for a microscope, angle subtended at the eye, final image by the final image by the microscope. This numerator you will understand when I teach you simple compound microscopes. But denominator already now you understand. Denominator is what? Angle subtended at naked eye, angle subtended at naked eye by the object when the object is at the near point. So you are very clear what this says. This says that now let's say now there's an object. Now we are using microscope to enlarge very small object. For an example, let's take an ant. Let's take an ant. Right now, see this is my ant. Can you see the ant? Can you see an ant? Shall I find an ant and shall I show you? Normally, there are many ants in my home, and many creatures are in my home. Karapotta, cockroach, everyone is there, but today I can't find any of them. Right? So I will take one ant. Just think that's an ant, very small ant. So, right now, just think this is my what? This is my microscope. My eye, my microscope, my ant is here. I am looking the ant. Ant is my object. Ant is my object. I am looking the ant through the microscope. Microscope means think like convex lenses. Microscope is convex lenses. My object is ant. Through the lenses, I am looking at the ant. So you know that then there will be an image of that ant. There will be an image of the ant, right? That image, that final image of the ant, final image of the ant, subtended at the eye is this one, right? Denominator is when I remove my microscope and when I bring that that object to my near point. When I bring, this is my eye, when I bring that ant to my near point is how much? 25 centimeter. When I keep my ant here, 25 centimeter from my eye, when I keep that object, when I keep the ant at my near point 25 centimeter, angle subtended at my eye by the ant, angle subtended at my eye by the ant is this angle. Did you understand? Right? Okay. Do you understand something? Raise your hands. Okay, right. Time is 9:15. Started the class at 8:40. Genuinely hands up this story. Do you understand? Hands up. Raise your hands. This story. Up to now, story is very clear. Hands up. Just hands up quickly. Hands up quickly. Story is very clear. Hands up. Raise your hands. Very clear story. Hands up. Very clear story. Story is very clear. Very clear. Right? Okay. Then okay. In the beginning, there are definitions. Then okay. I hope don't worry about the numerator, but you should have understood what is this denominator says. Whatever the object, take to your near point, angle made by that object is your denominator. That story is done. Okay. Now we can talk about, okay, right. That story is done. That story is done. Then do you think angular magnification have units or dimensions? No, right? Angular magnification does not have any universal dimensions. That story okay, right? Okay, right, okay, right. Now I will tell you simple microscope normal adjustment. Right. Look here, this story now. They are after story. Based on whether your microscope is at normal adjustment or abnormal adjustment, what is varying? Right. If your microscope is at normal adjustment, you can adjust your microscope into abnormal adjustment. Then again, I want to tell you another point. For a healthy eye, we just define what is near point. So I want to teach you for a healthy eye, what is far point? Any prediction? If you have a very healthy eye, the minimum distance that you want to keep an object to see clearly is near point 25 centimeters. What is far point? The maximum distance that you can keep an object in front of the healthy eye to see that object very clearly, right? But keep in your mind, normally far point is infinity. For a healthy eye, far point is infinity, right? Like near point, far point is infinity. Far point is, keep in your mind, infinity. It means so much large distance. Okay. Now, so okay, right. Oh, okay. What is this normal? Now, I have a doubt. Even in the theory class, also, I had a small doubt. Now, what is this normal adjustment and abnormal adjustment? I don't understand. I don't understand. Story is very simple. Normal adjustment and abnormal adjustment, what are we going to do is, we are going to change the location of the final image, right? By using our microscope or telescope, by putting into normal adjustment to by putting into abnormal adjustment, what are we going to do is, we are going to change the location of our final image. We are going to change the location of the final image, right? In normal adjustment, abnormal adjustment, what's happening? Basically, what are we doing? Changing the location of final image, right? Changing location or position or whatever. Changing position of final image. Final image. Final image. So where are you going to change? Based now, when you shift to normal adjustment to, when you shift to abnormal adjustment, yeah sir, you are going to change the location of the final image. Where to where? You are going to shift between, near point and far point. You are going to shift between near point and far point. Near point and far point. You are going to change the final image location to near point or far point. Based on the story, you can define normal adjustment to abnormal adjustment. Right, okay. For a microscope, I will ask you a question. For a microscope, you know why we are using a microscope? Uh, to see smaller objects nearby us. To enlarge smaller objects nearby us, we are using microscopes. What is normal? What is normal? Just you think what is normal? What is normal? What is abnormal? When a boy wears a trouser, when a boy wears a t-shirt, it's normal. But when a boy wears a frock, it's abnormal, right? Very similar way, we are using microscope to enlarge smaller objects nearby, right? Just you imagine what is normal. Using microscope, the object is nearby you. Using the microscope, you are going to create an image. Placing your image at your near point is normal. placing that image at the far point is normal. What do you think? Right? There is an ant nearby your eye. Using microscope, creating ants image at your near point is normal. Oh, creating ants image at the far point, infinity is normal. Raise your hands. Raise your hands. Creating ants image at the far point is normal. Hands up. Creating ants image at the far point is normal. Hands up. Hands up. Creating ants image at the near point is normal. Hands up. Creating ants image at the near point is normal. Hands up. That's the story. That's the story. Then as a story, normal adjustment for a microscope, normal adjustment for a microscope, if you can create the final image of the object at the near point, that is normal adjustment. Normal adjustment. What is abnormal adjustment? Special adjustment. Your object, your ant is nearby your eye. Using the microscope, you are creating ant's image at the infinity, at the far point. That's abnormal. That's abnormal. Creating final image at the far point. Abnormal adjustment. Abnormal adjustment. Then tell me from this equation who is going to change. This one is not going to change. Denominator is always same. But final image, look here, look here, look here. If it is near point, if you are, if sorry, if it is normal adjustment, if it is normal adjustment, final image is at the near point. If it is abnormal adjustment, final image is at the far point. This is the overall idea. Overall idea. This is the overall idea. Overall idea. Right. Shall we take a small break and come? Hands up. Let's take a small break and we'll discuss. Now I want to teach you now. Now when I draw the ray diagrams, you will understand very clearly where how to draw the ray diagram very clearly. Need a small break. Hands up, sir. Will since we are talking, shall we take a 5 minute to 10 minute break and come? Hands up. Need a small break. Hands up. Need a break. Hands up. Need a break. Need a break. No need a break. Oh, no need a break. You guys don't want break. But I won't break. But I won't break. I know you are very energetic, very keen, very eager to learn, study, a level closer, want to win, right? Somehow want to win, somehow want to jump. But since I am old, I am lazy teacher, right? I am very alert teacher. So therefore, I won't break. Shall we take 10 minute break? Is it okay? 5 minute break or 10 minute break? I will take 10 minute break and I'll come. 9:25. I will come at 9:35, 9:35, 10:35, 10:30, 10:40. I'll come at 9:35. What you do? What you do? Look here. What you do? Revise it. Huh? Revise it. If you have a notebook, refer your notebook also. Right? If you have a notebook, refer your notebook also. It's a very I'm telling summarizing because some teachers they can't teach this way, but it's okay. Right? It's a revision class, but without knowing this, you can't understand the story. Therefore, I want to teach in this way only. I will take a small break and come. Come at 9:35. I'm giving breaks for a reason. Okay, come 9:35. Okay, fine, fine. Okay. Wash your face, drink something, eat something. Chill and come. Uh, right, right. Simple microscope, right? Simple microscope. Look here, the story. I keep this one for our understanding. I don't erase. I keep this one. Then you can understand the whole stories. Simple microscope. First one is normal adjustment, right? Simple microscope. Normal adjustment. Simple microscope. Normal adjustment. Normal adjustment. Right. Now you will understand much better way what does it mean by simple microscope under normal adjustment. You will understand now. Adjustment. Right. Okay. As I told already, simple microscope means one single convex lens. One single convex lens is a simple microscope. Right. Look here. Simple microscope means one single convex lens. Now very carefully listen the ray diagram. Right. Then there is only one single convex lens. Convex lens. Generally keep in your mind, focal length of convex lens in simpler microscope is smaller value. Normally, focal length is smaller value. Keep in your mind, simple microscope, focal length is smaller value. Normally, focal length is a smaller value. Smaller, right? Okay. Now, you know that optical center, focal point, and we know what is center of curvature, right? We know what will happen. Now you are going to keep your object. Now let's say now you are going to place your ant. Ant is your object. Ant is your object. You should keep your ant in between. You should keep your ant in between optical center and focal point, right? That means here is your object. This is your ant, right? This is your ant, right? Very carefully listen. Your object. Optical center, the same mark is P. Optical center is P. Focal point is F, right? If you are using simple microscope, first point is, if you are using simple microscope, first point is object should be in between optical center and focal point. Your object should be in between. Object should be in between optical center and focal point. That story. Okay. Then you know where will be the image. Then you know where will be the image. We learn the story. Right? If you do, you can do the ray diagram also and you can decide the final image location. But already you know that. Can you tell me the characteristics of the image? We learned in division class. When your object is in between optical center and focal point, your image will be virtual, upright, enlarged, behind the object. Behind the object. So I will draw that using ray diagram. I will use the ray diagram also. Look here. We all know that light ray passing through the optical center does not refract. First standard ray diagram. We talked about three ray diagrams. Three standard rays. Light ray parallel to the principal axis after the refraction passes through the focal point. So when you extend these two light rays backwards, when you extend these two light rays backwards, we all know there will be an image behind the object, vertical, upright, enlarged. So this is the final image. This is the final image final image produced by the microscope. Final image produced by the microscope. Right? Right? Story is clear, right? This is the final image. Okay. Now they ask in your exam, definitely if they are asking question from optical instruments, first they ask you to draw the ray diagram. Then they ask you to derive the angular magnification equation. So therefore, it's no use if I just write the final equation for angular magnification. No use, because in your exam essay question, definitely if they are asking a question from optical instrument, they will ask you to draw the ray diagram. For example, draw the ray diagram for a simple microscope at normal adjustment, right? Abnormal adjustment, right? That's what they are asking. Now, normal adjustment means where should be your final image. If it is normal adjustment, if your simple microscope is a normal adjustment means final image should be at the near point. Final image should be at what point? Near point. So from the lens, if you measure the distance to the image, that should be near point 25 centimeter. 25 centimeter, right? This is also important point, right? If it is normal adjustment, if the simple microscope is a normal adjustment means final image is at the near point, 25 centimeter from the lens. Did you understand? Now I will teach you. Let's learn how to derive the equation for angular magnification. Look here. Look here. Angular magnification equation. Look here. Right. So if I draw, look here, if I brief this diagram again for our understanding, if I show the diagram, this is our lens. Then this blue color light ray, look here, this blue color light ray, if I short it, and my object, this is my object, can you carefully listen? And this my image. Normally image should be drawn in dotted lines. Image should be drawn in dotted lines, okay, dotted lines. Image. Now what is this one? What is this one? Angle subtended at the eye. Eye means eye is closer to lens only. Your eye is closer to lens only. Think lens as your eye. Angle subtended at the eye by the final image. By the final image. By the final image. Angle subtended by the final image at the eye. At the lens. At the lens of the microscope. Then this is we call as alpha dash. Right? So this is the alpha dash angle. Right? This is alpha dash. What is alpha dash? Angle subtended at the eye by the final image. Right? No, near point means near by the final image at the microscope. Then this distance, this distance is capital D. This gap is, capital D. Right? Let's say I say that height of the object is simple HO. Very carefully listen. Height of the image is simple HI. HO, HI. Now today I think we have to, it's a big discussion. It's okay what to do. Have to do in this way only. Right. So then shall we derive the equation for angular magnification? We know angular magnification means capital M. That is equal to alpha dash over alpha. Numerator angle is alpha dash. Denominator angle is alpha. So this thing normally what we do, we consider these values are very small and we take their tan alpha values. Tan alpha dash, tan alpha. Right? Tan alpha dash, tan alpha. Right? Capital M means tan alpha dash over tan alpha. Now alpha dash, where is my alpha dash? Here is my alpha dash. This is my alpha dash. Now when you consider this right angle triangle, tan alpha dash means opposite. Opposite is HI, adjacent is D. I can write down, see this is important. HI over capital D. Tan alpha dash, am I correct? Tan alpha dash means opposite. This right angle triangle, opposite is HI, adjacent is D. Over, over, tan alpha. Alpha. Alpha means what is alpha? What is alpha? This is alpha. Keep it in your mind. This is alpha. This is alpha dash. So what is alpha? Alpha means angle subtended at naked eye. Angle subtended at naked eye when the object is at near point. Then object, look here, object. When you bring the hand to the near point, when you bring the hand to the near point from your naked eye, object head is H only. Then what is tan alpha? Tan alpha means opposite is H naught, adjacent is capital D, near point capital D. So you can write down tan alpha is what? H naught over capital D. Then we are getting angular magnification as what? DD cancel out. Finally, you are getting HI to HO. HI to HO. Am I correct? You are getting HI to HO. Up to now, everything is now I am going to derive. Finally, I will write the final equations also. But I can't avoid deriving in the revision class because I will teach you the story. Then only you will be able to derive in the papers. Up to now, story simple answer. Up to now, story simple answer. Story is okay. Story is okay answer. Story is okay. Story is okay. I can teach you in simple way, but this is the way we want to learn. Story is simple, okay? Right. So now what you want to do? Now you want to use lens equation. Let's say now you know the focal length of your lens. You know the focal length of your lens is simple less, right? So then you know final image distance is capital D 25 centimeter. I wanted to find an equation for angular magnification. Unfortunately, I ended with HI over HO. So you know what you do. HI over HO means we know V over U, okay? Right? V over U. What you can do now, consider this lens, apply lens equation. Object is here, image is here, image distance D, focal length of the lens is simple left. Apply lens equation. When you apply lens equation, right? When you apply lens equation, I can't erase any of them. When you apply lens equation, right? So you know the equation 1 over V minus 1 over U equals 1 over F. Then you know I taught you sign convention. Sign convention, look here. Sign convention, if it is convex lens negative, you know reason, direction of light, or light rays passing to the right side direction, distance measured opposite to the direction of light are positive. Now object distance is also this direction, image distance also this direction. So therefore both are positive. Both are positive. Sign convention, right? What I do, I know image distance D, I know focal length, but I don't know object distance. I don't know. So look here, what I'm going to do is, I thought of multiply all the terms by image distance V. Then you are getting here V over V minus V over U minus V over F. I thought of multiply all the terms by V. We can do it. We can do. Just learn by this method. It's very important. Very important. Then I will end up with, look here, V over V means 1 minus V over U minus V over F. Right. Okay. Now, lean angular magnification means HI over H naught. We know HI over H naught means V over U. Then I can tell V over U means what? V over U means my angular magnification. V over U means my angular magnification. This is my angular magnification minus 1 minus, what is your V? In this scenario, your image distance is what? In this scenario, your image distance is what? Reply everyone. In this scenario, your image distance is what? Reply everyone. Reply everyone. What is your image distance scenario? Reply everyone. Reply everyone. 25 centimeters, if not capital D. 25 centimeters, if not capital D. Capital D, capital D over F. Finally, the equation. Angular magnification for a microscope at normal adjustment. Microscope at normal adjustment, you are getting D over F plus 1. Actually, I can, in the revision classes, up to now, I have done like that only, but this optical instrument part, I can't do that. Then you don't understand what is that. So that's why I'll deride all the derivations. I deride all the derivations, right? I'll deride that all the derivations. Can't see the board. DOF plus 1. Capital M means DOF plus 1. I write down here. Capital M means D over F plus 1. Plus 1. Genuinely hands up. Now thereafter, now genuinely hands up. Did you understood? Now in MCQs, what they give, they ask you to find the linear magnification. They ask you to find the angular magnification. Now, brief it. Angular magnification means alpha dash over alpha. You know what is alpha dash? Angle made by image. Alpha means angle made by object. You know what is exactly alpha dash and alpha for a microscope. If it is normal adjustment, you know final image is at the near point. If it is abnormal adjustment, final image is at the far point. Right? So then they ask you to derive the angular magnification equation. Tan m means alpha dash over alpha, tan alpha dash over tan alpha, something, 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 something. This is the result. You should learn by heart this result. You should learn by heart simple microscope, normal adjustment, angular magnification equation is DOF plus 1. DOF plus 1. DOF plus 1. Right. Okay. Up to now, this story, did you really understand? Let's say how many of you understood hands up? Time is 10 o'clock. Level 1.5 hour only I have. Anyhow, I want to finish optical instruments. Hands up. Up to now, everything is very clear. I want to finish optical instrument also. But it's not a theory class also, but it's like a theory class only. Now it seems like a theory class only. Hands up. Story. Story clear. Clear. But with a short time, I'm explaining everything. But I can't explain more. Right? Can't explain more. Right? Okay. And now you can simply derive, you can simply understand. Then in abnormal adjustment, what is the change and what is the equation? Right? Normal adjustment is the story. Then you can define in abnormal adjustment. Abnormal adjustment. So I erase this part. I erase. If I erase this is also important. I erase. I erase this part and I will do something. Abnormal adjustment. Okay, because this is we won this one. Abnormal adjustment. What is the story? Abnormal adjustment. What is the story? Abnormal adjustment. What is the story? In abnormal adjustment. Shall I erase this one? Finish writing? Hands up. Who's still writing hands up? Still writing hands up. In abnormal adjustment, look here, next story. Simple microscope, abnormal adjustment. If not special adjustment or whatever. Abnormal. You know, abnormal, what is the difference? Simple microscope means one lens. Object is definitely in between optical center and focal point. If the microscope is at the abnormal adjustment, final image should be at the infinity. Am I correct? There is only one convex lens. There is only one convex lens. Okay, there is only one convex lens. Okay, right? If it is abnormal adjustment, final image should be at the infinity. Then tell me where should be the object? Where should be the object? We learned. We learned in the revision classes, lenses we learned. Final image is at the infinity. If it is abnormal adjustment, final image is at the far point, at the infinity. Far point means infinity. To create final image at the infinity, where should we keep our object in front of the lens? Reply, everyone. Exactly at the reply, everyone. Reply, everyone. Exactly where? Only two responses. In order to create final image at the infinity, this final image at the infinity, where should you keep your object? Where should you keep your object? Exactly at the focal point. Exactly at the focal point. Right, that is difference. Then you know the ray diagram. Only one lens, same story. Look here, same story. Focal point, optical center is P, center of curvature here somewhere. Now, if it is a normal adjustment, object should be in between optical center and focal point. If it is abnormal adjustment, your object should be exactly at the focal point. Exactly at the focal point, important point. Then your object is at the focal point. Then you know, if you do the ray diagram, you know, you know how to do the ray diagram. We learned these stories. Light ray passing through optical center does not refract for the same path. Then this one is also parallel. We learned these stories in the revision classes. Check the lenses section. Then when you extend the light rays are parallel. Your image will be at the infinity. Am I correct? This is the abnormal adjustment. Right? Look here. Okay, right? Okay. Object height is h naught. This is focal length. Focal length. If I simplify this diagram like this, lens, this is your lens. Look here. This is your lens. And this is your object height HO. This gap is focal length. This light ray. Look here, this light ray. Now tell me, now you want to find angular magnification for abnormal story also. Angular magnification for abnormal story also. How can do this one? Same thing. Final image infinity. Final image at the infinity. Angle made by final image. Final image at the infinity. Right? Final image at the infinity. Angle is this angle. Alpha dash is this angle. This angle is your alpha dash. Right? Alpha? Same alpha. When you bring the object to the near point in front of the naked eye, same alpha. Shall I derive the equation? Hands up, how many of you can derive the equation? You want to derive angular magnification in terms of capital D and F. I derive it. Same story, same way. Start from the beginning. When you start from the beginning, look here. Capital M equals alpha dash over alpha. That means tan alpha dash over tan alpha. Capital M means tan alpha dash tan h naught over f. Right angle triangle opposite h naught adjacent f over tan alpha opposite h naught adjacent d, h naught over d. See, h naught cancel out. We can easily get the answer DOF. Simple microscope story finished. Simple microscope done. Simple. Simple. Right? Right? DOF. Okay. Summarize it. Simple microscope, that's it. Then I will talk about compound microscope. Then we can finish the class. Don't worry. I plan to do sound also, but we'll see. We'll see. Right. Summary. What you want to remember. Right. Simple microscope. If I talk about normal adjustment, my object is in between optical center and focal point. My image will be at the near point, capital D, 25 centimeters. Angular magnification equation is, for simple microscope under normal adjustment, D over F plus 1. D over F plus 1. Okay. Then simple microscope abnormal adjustment. In that case, my object should be at the focal point. Image, final image is at the infinity. Final image is at the far point, infinity. In that case, angular magnification of simple microscope at abnormal adjustment, DOF. DOF. This story crystal clear answer. This story crystal clear answer. Crystal clear answer. Crystal clear answer. Crystal clear. Normally, they take 2-3 days to discuss this part. Huh? Crystal clear answer. Crystal clear. Crystal clear. Hands up. Hands up. Hands up. Okay. Done. Done. Finish writing hands up. Shall I erase the board, entire board? Now you know the story. Now I'm erasing entire board. Shall I finish writing hands up? Finish writing. Finish writing. Finish writing. 10 o'clock. 10 o'clock. I will do until 11:30. I have to do 8:30 when I start the class. At least I want to do 3-hour session. I will do until 11:30. I don't know how many of you will stay. It's okay. I have to do it. I have to do. It's my responsibility. Okay. Finished. Now, what we do? Now compound microscope. Now easy. Story simple. Compound microscope. Story simple. Same theory. Compound means there are two lenses. Now I will teach you compound microscope normal adjustment. This is somewhat complex. Keep your focus, but if you keep focus, you will be able to understand. You will be able to understand. Uh, right. Right. Okay. Hmm. Right. These are the main key things. Okay. Right. Compound microscope, there are two lenses. Okay. Compound microscope normal adjustment. Compound microscope at normal adjustment. Right, okay. Then story finished. The last few parts. Normal adjustment. One last time, just revise them, then enough. Prepare a short note. I'm happy that there's a girl. That girl, what she has done, uh, every revision session, because I brief the theory points only, important theory points only, I brief it and I teach in the revision session. What she has done, I shared that video also. She took nice half sheets and every that revision discussion, like this optical instrument, gas laws, mechanics. She has taken half sheets and all the important points. She roughly all the important points beautifully she marked in that papers and she combined them. Right. Then she has set of half is like that. Right. I think she's messaging me many times because she's telling, "Sir, I want to do this somehow. I want to get 3 A's. Support me, help me, give the idea, advice." So I never thought that these revision sessions I never have done for my previous, for just quick revision I never have done. But many students I think get the benefit. I'm very happy with that. Okay, right. Okay, no time. Can talk. No time. Okay, right. Okay. Like to talk. Time is the problem. Now two lenses. Now this scenario they have two lenses. They have two lenses. Okay. Uh, there are two convex lenses. There are two convex lenses. So we are calling names for them. The convex lens goes closer to the object. We call it as objective lens. The lens closer to the eye, we call it as eyepiece lens. Right. Now, normally we keep our object this side. We are looking through this device. Our eye is somewhere here. Our eye is close to this lens. Here is our eye. Object is here. So therefore, this one we call it as objective lens. Objective lens. You write down now objective. Objective lens. Focal length is f. Objective lens focal length is f4. Objective lens focal length is f4. So this lens we call as eyepiece lens. Eyepiece lens. This one objective. Objective eyepiece. This one focal length is fe. But normally for a compound lens, first important point is, for a compound lens, keep in your mind, the first important point is, uh, keep in your mind, right? First important point is, keep in your mind, for a compound lens, eyepiece lens focal length is greater than the objective lens focal length. Normally, this fe is larger, right? Keep in your mind, the first point is, fe is larger than the fo. First important point. Eyepiece lens focal length is larger than the objective lens focal point. First important point. Right, okay. Then eyepiece means closer to the eye. Closer to the eye. Closer to the object. Focal object lens is closer to the object. That's the story. Okay, right, okay. Right, okay. Right, okay. Done, okay. I understand only. Normally, you already noted. Simple microscope, under normal adjustment, we keep the object in between optical center and focal point. Abnormal adjustment, in abnormal adjustment, we keep the object at focal point. In compound microscope, we are keeping the object in between focal point and normally center of curvature, right? Normally, yeah. What we do, we keep our object in between focal point and center of curvature. So our object is in between focal point and center of curvature. This is our object. So then you know that with the lens knowledge you can tell when the object is in between focal point and center of curvature, where will be the image? This side, inverted, enlarged, because our ultimate goal is making this object more and more large. Our ultimate goal is making the object more and more large. We use two lenses to enlarge more and more our image. I will tell you. Right? Keep your object in between focal point and center of curvature. Then we know our image will be in this side. beyond the focal point, is sorry, beyond the center of curvature, enlarge one, inverted real, right? If you draw the ray diagram, you know that story. I do the ray diagram also. Then we are using two standard rays. Always light ray passing through the optical center does not refract. Then the second standard ray is light ray parallel to the principal axis. After the refraction, passes through the focal point. After the refraction, passes through the focal point. So here is my F naught. Here is my F naught. Careful listen, huh? Careful listen. Right? This is a good revision also for you all. F naught. Then we know here is our first image. In the simple microscope, there was only one image formed. That is our always final image. But in compound microscope, keep in your mind, there will be two images. For this IP, for this objective lens, this one is the object. It creates enlarged image, inverted, real, enlarged image like this. This is the first image. This is the first image. This is a larger one. I mark it as I1. I mark it as I1. Right? Then, look here. Right, okay. Then forget about this lens story. These two light rays goes like this, okay. When you consider objective lens, this is the object between focal point and center of curvature, created enlarged image, inverted real, I1. For the second lens, keep in your mind, right? Who is the object? Second lens doesn't know there's an object here. Second lens always think, this is my object. Second lens thinks, this is my object. But actually, this is the image produced by the objective lens of this object. But second lens doesn't know this guy. Just think that now in front of me, let's say there is a girl. Amaya. Behind Amaya, there is a boy. Let's say Navas. For me, I don't see Navas. I see the Amaya. The same story, right? For this lens, thinks that this one has the object. But actually, this is the image of this object. So this second lens, eyepiece lens thinks, this is the object. Eyepiece lens thinks, this is the object. But keep in your mind, I'm summarizing, I can explain detail, but it takes so much time. But keep in your mind, when you consider focal length of eyepiece lens, okay. Now hereafter, same story. What is the story? Can you remember simple microscope, normal adjustment, where was the object? In between optical center and focal point. Then image was a virtual upright, enlarged behind the object. Now hereafter, same story is applicable. Now this one, think this one as your previous simple microscope lens. Just think this one as your previously discussed lens, your object. Then this object should be between focal point and center of curvature. Then right now this object is So sorry, my bad. This object should be, for this lens, this object should be between optical center and focal point. Then the focal point of this lens will be somewhere here. Then where will be the image? This one's image will be behind this object, enlarged virtual one. Am I correct? If I do the diagram, if I do the diagram, use two stand ray diagrams. Light ray passing through the optical center does not refract. Light ray parallel to the principal axis passing through the focal point. Passing to the focal point. So when you extend these two light rays, when you extend these two light rays, if you have doubts, please ask. When you extend these two light rays, backward direction, here will be your final image. This is your I2. I don't know how many of you getting the idea. Right? What is the story? Okay, look here. Raise your hands. Do you understand the story? Hands up. Anyone understand the story? Now this is also, look here. Look here. Okay, I will give an idea. I will give an idea. Right? I will give an idea. Right? I will give a small idea. Okay. Now, just imagine this lens as the. Just imagine this lens as the simple microscope normal adjustment lens. That's it. Then this red color drawing is, the red color drawing is same as the simple microscope normal adjustment. Am I correct? Only thing is, previous diagram, this one was upwards, image is also upwards. Just only think about red color diagram. Only difference is this one is object is downwards, image is downwards. So then why, sir, why have you used another lens? Very clear. Why? Our ultimate goal is to make the image more and more larger. By using another lens, we created larger image of this object. We created larger image of this object. That image enlarged further using that lens. This is the story. This is the story. Right? Anyone, do you understand story answer? How many of you understand story answer? Story? I don't know how many of you understand story. How will the first image exactly form between focal point and center of curvature of second lens? We want to adjust it. Somehow you want to adjust the lens and you want to bring, you want to somehow, you want to form this object's image exactly in between this one's optical center and focal point. That's why you are adjusting. You are adjusting. So in that telescope, you have done that similar thing. If not that, what we call what binocular also something also you are doing that adjustment only, right? Okay, 1020, 1020. If you understood the story, telescope also nothing. Okay, am I making this scenario difficult? Just reply. Am I making the scenario difficult? Am I making this scenario difficult? Reply. 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 Am I making the scenario difficult? Reply. Reply. No. Just come. If you compare it, that's it. Now I don't know whether how you learned these stories in your classes. Just think simple microscope normal assessment diagram. Look here, okay, I will do that also. Now it's going to be a theory class. Yo, I want to make a revision class. It's a theory class near you. What to do? No need, no need, no need, no need, no need to explain like that. No need, right? No need to explain like that, right? Uh, no need to explain like that, right? No need. Can okay. This is the way. This is the way. Okay. If shall I explain? 10, 20, 1 hour to go. Can finish. If you understood this one, can finish. Uh, right. Uh, shall I ask you one question then? Shall I ask on this question? Then? There are some students. Ni? Everyone reply in the chat box. Huh? Here is your I. Ni? What is the now? Here is your this is your final image. Ni? First image, second image. This is the final image. This is the first one. This is the second image. Right. My question is, what is the distance from this lens from your eye to final image? What is the distance? Let's see how many of you will answer. Let's see if you only look at the red color diagram also you can tell. If you only look at the red color diagram also you can tell. Uh, reply everyone. I need replies from everyone. Need replies from everyone. Only two replies. Three replies. Only three replies, right? If you only think about the red color diagram also you can tell. If from the definition. If this compound microscope is at the normal adjustment, I told you final image should be at the near point. Final image from your eye, final image should be at the near point. This is capital D. If not, this is capital D. Capital D. Then can you identify what is that alpha dash? What is that alpha dash? Alpha dash. Final image at the eye angle. Final image angle at the eye. This is alpha dash. Am I correct? Your eye is here. Alpha dash. If I simplify this diagram for our understanding, if I simplify it, look here. If I simplify it, simplified version. Simplified version. Simplified is my object. Okay, I mark in blue. Look here, this is my object. Right. Then the light ray, this one. Simplified. Now here is my image. My image. Image. I1. Right. This is object O2. For this one is the object. Then light ray. If I do the light ray, this one. Very careful, listen. Then this story. Final image is somewhere here. I think this space is not enough. Somehow stay focused and cover this, okay? I am taking time for all of you to understand because So therefore, get the maximum benefit. I can quickly finish it. You know my talent, right? You know my talent. But then also can't draw the diagram, I think. Oh God. Your final image. Here is your final image. Final image. Right? Very careful listen. Very careful listen. Huh? Simplified diagram. After class finishes, put a reply with the you understood or not the story, okay? What is alpha dash? So we know this is alpha dash. If I simplify, this is alpha dash. Shall we write the equation? Then object height is let's say h. First image height is h1. Object height is ho whatever. Second image height is h2. And you know this distance, capital D. Here to here, distance you will know capital D. Right? This gap you will know capital D. Right? Okay. Capital M. Start from the beginning. Angular magnification. Look here. Angular magnification means we all know that alpha dash over alpha, tan alpha dash over tan alpha. Tan alpha dash means we all know. The tan alpha dash means alpha dash. Tan alpha dash means H2, this large right angle triangle. When you consider large right angle triangle, H2 capital D. H2 over capital D. H2 over capital D. Am I correct? Over tan alpha. Naked eye. Naked eye. Where is my naked eye? My naked eye, bring the object to my near point. Bring the object to my near point. Angle at the eye. Angle at the eye. Tan alpha means H over D. H over D. Am I correct? Am I correct? Right. Now what? Now what? Now we know that DD cancel out. Capital M means H2 over H. Capital M means H2 over H. Right. Now some modification. What we do normally, you also practice. This is in the exam. If they ask you to derive the angular magnification equation for compound microscope under normal adjustment, after you coming here, remember you want to multiply up and down by h1 h1. The standard way. You want to multiply up and down by h1 h1, height of the middle one. There's a reason. Then you can write down h2 over h1. See, h2 over h1 into h1 over h. H1 over h. Look here. What is h2 h1? This is okay, right? But after you came to a after you reach this one, you want to multiply numerator and denominator by h1 h1. Don't ask why. This is the way. Without doing this, you can't derive the equation, right? So then you can write down h2 over h1, h1 over h. What is h2 over h1? H2 over h1 means what is that? Okay, I will ask from you. Reply. You guys reply. H2 over h1 means what? Any idea? H2 over h1 means what? Any idea? Reply, you guys. You have done these things. H2 over H1 means what? 10:30, 1 hour I have there. Magnification of eyepiece. Very good. Eyepiece lens ne? Objective lens, eyepiece lens. H2 over H1 means we all know magnification of linear magnification. Huh? Linear magnification of eyepiece. Final image height for this eyepiece lens, object image. Image height H2 over object height H1. This is the linear magnification of eyepiece lens. They ask this in your exam MCQs. Learn by heart. Angular magnification of compound microscope in normal adjustment equals linear magnification of eyepiece lens, H2 H1. Linear magnification of eyepiece lens into linear magnification of eyepiece lens into H1 over H means what? H1 over H. H1 over H means again linear magnification of objective lens. Linear magnification of objective lens. Objective lens. Very important equation. Learn by heart. In your short notes also, write this one. Right? I will ask you one question. I will ask you if I write, I don't know how many of you agree with me. If I write now, just think about this one, eyepiece lens. Eyepiece lens. Eyepiece lens object is between optical center and focal point. Image is away, virtual, enlarged. If I write, how many of you agree? I don't know. If you feel yes, then raise your hands. If I write angular magnification, if I write angular magnification, if not M, if I write ME, instead of ME, if I write D over FE plus 1, how many of you agree? Angular magnification of eyepiece ni. Angular magnification of eyepiece ni. If I write instead of capital ME, D over FE plus 1, how many of you agree? Hands up. No idea, ni. It's getting complex. Complex. Okay. We'll derive. Derive it quickly. Look here. Look here. Now, in the question, they give this data. They give this distance as V. I'll give some time. I'll give some time. Look here. You want now you want to get the final equation for angular magnification. We came angular magnification means linear magnification of object lens into linear magnification of eyepiece lens. So you are going to derive the final equation. You are going to derive the final equation. So what you do now, given data, they have given this distance. For the objective lens image distance, they have given as V. Focal length FO, focal length FE given, and capital D is given. So what you do, quickly consider objective lens, apply lens equation, consider objective lens, apply lens equation and get an expression for H1 of H quickly. Consider objective lens, get an expression for M linear magnification quickly. Lens equation 1 over V minus 1 over U equals 1 over F. Sign convention. Convex lens minus object distance, light is passing to the right side direction, but your object distance is opposite to the direction of light, therefore negative. Image distance is in the, therefore positive. Huh? Now object distance is left side, light is passing right side, direction of distance is opposite to the direction of light, positive. Image distance in image distance direction is same as the light direction, negative. Minus 1 over V, minus 1 over U, minus 1 over F, all minus cancel out. Then you can write down 1 over V minus 1 over U equals 1 over F, 1 over V plus 1 over U equals 1 over F. Now, V given data, F not given data. I want to write an expression for H1 over H. That is the linear magnification. That is the linear magnification, right? If not, this is equal to what? V over U. I thought of multiplying all the terms by V. If I multiply all the terms by V, look here, I will get that. Look here, V over V plus V over U. V over F focal length, it's an objective length FO. V over V means 1. V over U. H1 over H means what? H1 over H means H image height over object height. Image height over object height means what? That is the image distance over object distance. So what can I do? This is what? This is H1 over H, if not M naught. M naught equals V over F. Then I can substitute my M naught means V over F naught minus 1. Right. Right. I can write down my M naught as what? V over F naught minus 1. Finally, M naught linear magnification. Now, angular magnification of the compound microscope under normal adjustment means multiplication of the linear magnifications of objective lens and eyepiece lens. I found somehow linear magnification of objective lens is what? V over F naught minus 1. This part is V over F naught minus 1. Up to now, genuinely, did you understand? There is one last part. There is only one last part. Up to now, genuinely, did you understand? Hands up. If you don't understand, ask your questions. If you understood, hands up. If you understood, hands up. Understood, hands up. Right? So, what is that simple h? Where it came from? Simple h means object height. This object is simple h. H naught means simple h. Object is simple h. Image height is h1. The last image height is h2. Hands up. Up to now, everything is very clear. Hands up. Up to now, everything is very clear. Hands up. Up to now, everything is very clear. Hands up. Very clear. If you have questions, you can ask. Then we want to derive the last one, ME. In terms of D, FE, it should be definitely D over FE plus 1. When your simple microscope is at normal adjustment, capital M is D over F plus 1. When your compound microscope is at normal adjustment, ME means D over FE plus 1 only. Shall we derive that one? Shall we derive that one? If not, will you derive it? Hands up, how many of you can derive it? Hands up. Hands up, how many of you can show that when we consider eyepiece lens, eyepiece lens, how many of you can show hands up this H2 over H1, if not capital ME equals D over FE plus 1? Hands up. How many of you can show this? Hands up. How many of you are confident H2 over H1 equals ME D over FE plus 1? Hands up. How many of you can do that? Hands up. That is very similar to that previous simple thing, simple microscope story, right? Hands up who want me to derive it. Hands up. Hands up who want me to derive it. Hands up. I will derive it. Okay, I'll derive it. Look here, I reach the boat. You take screenshots. Look here, this diagram, lens equation, 1 over V, 1 over U, 1 over F. Sign convention. Convex lens therefore minus Then look here, light is passing right side direction, but object distance and image distance both are opposite. Therefore, plus plus, right? I multiply. I know image distance d. This is the object. This is the image. Image distance is d. Object distance I don't know. I multiply all the terms by v. If I multiply all the terms by v, I can write down. I can write down v over v minus v over u uh, minus 1 over focal length of eyepiece lens is fe. Fe 1 v over u. V over u means we know. V over u means image distance over object distance means h2 over h1, right? Image height over object height. Image distance over object distance means what? Image height over object height. That means this is your capital ME minus. So this is also V, yeah? Multiplying all terms by V over minus FE. Your V is what? Image distance is the capital D. So you can write down capital ME means you all know D over FE plus 1. Finally, 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 angular magnification is done. What is the answer? Final answer. Angular magnification means, keep in your mind, for a compound microscope under normal adjustment, that is equal to multiplication of linear magnifications of objective lens into linear magnification of eyepiece lens. Further, linear magnification of objective lens. Linear magnification of objective lens, V over F naught minus 1, linear magnification of eyepiece lens, D over Fe plus 1. Plus 1. Learn by this equation. But if you are really wise enough, you can tell the angular magnification equation for compound microscope at abnormal adjustment. If you are really wise enough, you can tell the angular magnification equation for the compound microscope at abnormal adjustment. What is the only difference? In simple microscope, normal adjustment, final image at the near point capital D. Simple microscope, at the abnormal adjustment, final image is at infinity. Angular magnification equation, simple microscope, normal adjustment, D over F plus 1, abnormal adjustment, D over F. In this compound microscope story also, who is only going to change? Who is only going to change? Only the eyepiece side. Only the eyepiece side going to change. Right? I will tell you, I will explain. If you are really bright enough, you know the equation for the compound microscope at abnormal adjustment. What is that? V over F1 minus 1, D over Fe. D over Fe. Right? D over Fe. Okay, shall we derive it? So we'll derive that also. Right. Right. We'll take a small break. We'll take a 5-minute break and 5-minute break and we'll come. 7-minute break and we'll come. Okay. Generally, do you really understand the story? Tell me, guys, because if majority don't understand, no use of in this situation class, right? Do you really understand? Hands up, hands up. I ask every time I ask you to hands up. If I feel students don't understand, hands up. Do you guys understand? Hands up. Do you guys really understand? Hands up. If it's a theory class, I calmly teach. Within 2 hours, doing this thing is not easy, right? Hands up. How many of you really understood? Hands up. Understood? Hands up. I will teach you compound microscope abnormal adjustment. I will teach you. Up to now everything is very clear and genuinely yes, I understood, thinking that you all are understanding. Okay, you all are understanding. Okay, we'll take a small break. We'll take come at 10:55. Right. Listen, one last compound microscope abnormal adjustment. We'll do that. Okay. We'll do that. Then tomorrow also we are doing past discussion. Tomorrow we'll put this what telescope story tomorrow. Right. Today the last part compound microscope abnormal adjustment. I will do the ray diagram. Same derivation is there to be done. Right. So then I will tomorrow what I do, I will draw a short note of this compound microscope and simple microscope, and I will give a good summary also. Right? We'll do like the last part, the last 50 minutes last. Look here. But they didn't ask for this. They didn't ask this section for last few years. So therefore, there is a big possibility of asking one essay question from optical instruments. Right? Mostly they have asked ID effects stories only. So therefore, there is a very big possibility of asking an essay question from this section. That's the problem. Okay. Right. Abnormal adjustment. Abnormal. 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 I will tell that just when you compare normal adjustment and abnormal adjustment in compound microscope, ray diagram of objective lens doesn't change. Same as the normal adjustment ray diagram. Only change happens in ray diagram in eyepiece lens. Okay. If I draw it, look here. Can you remember in the previous diagram? In normal adjustment, objective lens, focal length is FO. In the previous, in the normal adjustment, where did we keep the object? In between focal point and center of curvature. In abnormal adjustment also, you are keeping the object the same location. Like where you kept the object in normal adjustment, at the same location, you are keeping your object in the abnormal adjustment as well. Same location, same object, same location. Then you will get your images also same as the previous location. In normal adjustment, where you got the image in the same location, you will get the same image because same objective lens, same focal length, same object, same location means your image also should be formed at the same place. That's why I told that there won't be any changes happening in the objective lens side. Objective lens side, there won't be any big change. Right? If you properly analyze it. If you draw a ray diagram, light ray passing through the optical center does not refract. Light ray parallel to the principal axis after the refraction passes through the focal point. Okay, here is your image. Just now, I think you have drawn the normal adjustment compound microscope diagram. Ni. Just compare. Same diagram like in normal adjustment. Same diagram like in normal adjustment. Object ID simple H. Image is I1. Image ID is H1. What is the now change? Now just go to the simple microscope. Just go to simple microscope. Uh, in simple microscope, abnormal adjustment, where is the final image? Infinity. where you kept your object at the focal point. Same story in compound microscope. In compound microscope, uh, in abnormal adjustment, in compound microscope abnormal adjustment, where should be your final image? This is the first image. For the eyepiece lens, this is the object and eyepiece lens creates an image. That is the final image of this compound microscope, right? Compound microscope, abnormal adjustment, where should be the final image? At the infinity. Then where you should keep the object? Focal point. Then this is the object for the eyepiece lens, right? This is the object for the eyepiece lens. This is the object for the eyepiece lens. Exactly, this should be located at the focal point of eyepiece lens. Then you know what will happen thereafter. If you draw the ray diagram, hereafter ray diagram, light ray passing through the optical center does not refract. Light ray parallel to the principal axis. After refraction, passes through the focal point, parallel light rays. In order to form final image at the infinity, in order to form final image at the infinity, in order to form final image at the infinity, final image at infinity, rays should be parallel. Am I correct? Don't you think this red color diagram, if not eyepiece sight, this eyepiece ray diagram is very equivalent to the abnormal adjustment in simple microscope? Don't you think? Same, very same, right? If I complete the ray diagram, these two light rays come and hit like this, right? These two rays should be parallel. Huh? These two rays also should be parallel. Then can't you derive the equation? If shall I write the angular magnification equation we derived for compound microscope at normal adjustment? I derive it at normal adjustment. Look here, at normal adjustment. The equation you can remember, equation angular magnification equals linear magnification of objective lens into linear magnification of eyepiece. Linear magnification of objective lens V over F naught minus 1 D over Fe plus 1. If I ask you, raise your hands, I'll ask you a question. Raise your hands. This is for the normal adjustment. Now I am talking abnormal adjustment. Raise your hands. How many of you say for the abnormal adjustment, if I modify the equation, capital M naught means same as V over F naught minus 1 answer? If I modify this equation for abnormal adjustment, capital M naught means same as V over F naught minus 1 answer? Same. Why? Same object, same location, same image when you consider objective lens, same focal length of the objective lens, then same equation. No change for this one. Only change is happening in this side. Why? Because now the eyepiece lens scenario is a bit different. This is your alpha. Final image is at the infinity. Alpha dash. This is your alpha dash. This is focal length Fe. Focal length Fe. If you derive the equation, right? Capital M means alpha dash over alpha, tan alpha dash over tan alpha. Tan alpha dash means this triangle, H1 over Fe. H1 over Fe, right? H1 over Fe over. Tan alpha means what? Tan alpha means you know that, naked eye. Naked eye, bring the object H to the near point D, alpha. H over D. H over D. See, H over D. See, looky. So you are getting something like this, H1 over H, D over Fe. What is this H1 over H? H1 over H means linear magnification of objective lens. That is V over F naught minus 1. This one is V over F naught minus 1 into D over Fe. What is D over Fe then? Linear magnification of eyepiece lens. Am I correct? I told you, right? In simple microscope, abnormal adjustment, angular magnification is D over F. If it is compound microscope, eyepiece site, D over F. Therefore, remember the equation for abnormal adjustment angular magnification is V over F naught minus 1 D over Fe. Story. Beautiful, very beautiful story. I don't know how many of you really understand. I don't know whether you learn these things properly or not. I don't know. I can teach you. But the time is the problem. Time is the problem. Right? I will tell you one point. Anyhow, we are spending very hard time these days. Right? You are also spending very hard time. Not only you are joining my classes, but you are joining other classes also. But it's okay. Please suffer that pain for this upcoming 6 months. This is very painful for you as well as for me. Suffer this pain for 6 months. Only 6 months there. Will work nicely. Please suffer. I know it's very difficult. Everyone can join to the session in the beginning. But keeping the focus and staying until the last second is not easy. Without missing any single point, grabbing all the points, quickly writing in your note all the points. Revision, we are not giving notes. It's difficult, I know. It's very difficult. This is only for 6 months. This suffer is only for 6 months. It's okay, suffer this pain. Then you will see a very nice feeling, very comfortable feeling once the result comes. Very nice feeling you will get. So then when you get A's, when your result is very beautiful, then you realize in order to get this result, how much of pain I suffered. Then when you remember that pain you done during your A levels, when you remember it, when you revise it, you get a small smile in your mouth. Therefore, these days suffer it. You know why? Our result is also coming. Then many people again start doing second shy. Because now when we go to the abroad also, the courses prices are also very high. And now the country is somewhat stable. What they do, most of them start doing their second shy. So then that's a big kind of risk for first shy people. If you are doing first shy A levels, if second shy people also engaging more after A levels, the competition is very high. So what you do, you work like beast. Work like beast, suffer the pain, right? That's a very big competition, right? You will see there will be very big competition after our result come. Many start working. From now onwards, you start working. From now onwards, you start working, right? From now onwards, you start working, right? then you can win. Right now, I don't know whether today's revision is effective or not, but this is not my pattern. Normally, my revision is not like this. Normally, it's 1 hour session only maximum, but I can't do that thing in the uh, optical instruments, right? Can I do? You think can I do? But I could have done something better, but the time is long. Now see, my plan is to discuss sound section also, right? But I realized when I was explaining the stories, many I felt like don't understand or something. I started to explain more. So then the time it took, right? We started at 8:10, a 20-minute break also, 11:15 minutes. We have taken more than 2 hours and 15 minutes to discuss this section. Right? Normally in theory classes, we are taking 3 days, normally 2, 3 days, but within 2 hours, we discussed oral idea. Right? Telescope section, we don't take that much of time. Very small idea only there. We can finish telescope section. Along with tomorrow, we'll do past papers also. Don't worry. But what I want actually from you all is, at least if you miss the sections before, at least you should learn from me properly. I don't know how many of you learn these stories properly. I don't know how many of you have seen before I explain. I don't know how many of you have seen there is a, when you consider compound microscope normal adjustment, there is a simple microscope in normal adjustment. I don't know how many of you have seen in whenever in a compound microscope under abnormal adjustment, there is a simple microscope at the abnormal adjustment. I don't know how many of you have seen. I don't know how many of you seen. I don't know how many of you have identified these relationships. Actually, I don't know. Right? So I want to teach everything properly. At least in these sessions, because in the revision sessions, I want to give that idea within the short time period. Any level student, anyone who look at the video, I want to make them very clear understanding. That's my plan actually. If not, I don't want to do this much of hard work for a revision class 4,000. Right? My target is something different. Okay. So I like when you come for a session, if there is any connection issue, stay until it finishes. Stay with me. We'll work. The revision, if you have learned already, again revising. Sometimes when you revise it, I think you don't catch these points, all these points. Even you have done this in your theory classes. But when you take the note and when you refer it also, sometimes it's not that much effective. Like I am quickly revising within 2 hours. When you revise also, you take at least 1 hour and half an hour by reading and revising. Within 2 hours, I am giving A to Z full story. Then I think this is very effective. Get the maximum benefit. Okay, get the maximum benefit. That's a story. 11:15. Now tomorrow morning we have to do. We'll work tomorrow morning. Tomorrow morning 8 a.m. 8 and 12. Tomorrow we want to do questions. Don't worry. Now we have 5 more months. I think unit 2, unit 3, unit 4. We can finish. Don't worry. We will cover everything in the quick revision also. Past papers, but we are doing everything properly only. Sometimes I'm planning to do another section but cannot do with the time, but that happens. But don't worry, we'll manage everything properly and we'll do everything with our best. Within these last 2, 3 months, we have covered lots of sections, right? Okay. The big sections are unit 2, unit 3, unit 4. 6, 7, 8, 9, not big sections, small sections. If I summarize it, very small. Therefore, don't worry, come and write the papers every day. I don't see people writing papers because I'm giving work plans, everything for the people who write the paper, right? So therefore, come and write the papers every day. And also, please put a small comment whether did you understand today's session. Actually, I'm not that much confident also. Just whether you really understood this simple microscope, normal, abnormal, compound microscope, normal adjustment. If you understood, put a comment. That comment, right? Okay. I think I don't want to talk more. I think 11:15 upcoming days we will work late night also. Yesterday we stopped the class. Yesterday also we did a small session. Yesterday we stopped the class around 12 o'clock. Likewise, upcoming days we'll work in midnight also. We'll work and we'll get 3 years. When you get 3 years and when you tell the results, I got 3 years, 3 years. It's not because of you, sir. It's because of my hard work. But there is a small support from your end also, sir. Thank you. If you like that, I'm very happy. Very happy, ni. Right? Very happy. Ni. It's a story. Story is beautiful. Okay. We'll find out for today's session. Genuinely answer. Today's session is effective answer. Today class is very effective answer. Effective answer. Today's session is effective. Really effective. All you are raising the hands. Uh, but I don't know. Okay, but I don't know. Okay, but I don't know. Okay, right. Put a small message with the really you answered or not. Okay, this one. Put a message, huh? And then we'll stop. We'll stop. You guys don't sleep. One last time, revise it. Prepare a short note. Okay, don't you sleep now. Simple microscope, normal abnormal, compound microscope, normal abnormal. That angular magnification equation definition. Take a small paper. Write only the important things. Right? Write only the important things. Prepare a small short note today before you sleep. Finished. We'll meet tomorrow. We'll meet day after tomorrow. Okay. Have fun. Good night.